Hello everyone! In this video, let me discuss to you the topic all about propositions in mathematics. Now, let's begin. What is a proposition? It is a declarative sentence that is either true or false, but not both. Now, let us define declarative sentence to fully understand what proposition is. Declarative sentence is a sentence that makes a statement. So, it states something. It also provides a fact. So, there's a fact on that sentence. It also offers an explanation. So, it explains something. Or, it even conveys information. So, the sentence is informing something. Also, it does not ask a question like, do you like chocolate? Since this sentence is an interrogative sentence since it's asking question. Or it does not also give an order like pass the chocolate please since the sentence here is an imperative sentence. Or it does not also express strong emotion like I hate chocolate since the sentence here is an exclamatory sentence. Now, for a sentence to be a proposition, it must be a declarative sentence. And here are the characteristics as what I have discussed to you. Let's proceed. In representing propositions, variables are used. In mathematics, variables refer to letters or symbols. In propositions class, the most commonly used variables are none other than letter P, Q, and R. These are the letters or variables used in representing propositions. Now, let's take a look on the following examples. We have here proposition P states that Balanga City is the capital of Bataan. Next, proposition Q states that Camiguin is in Mindanao. Lastly, proposition R states that 3 plus 2 equals 15. The following sentences are declarative sentences and therefore they represent proposition. Now, let's evaluate the propositions one by one, and that is by identifying their truth value. Let's begin with proposition P. Balanga City is the capital of Bataan. This sentence is true. Okay? So its truth value is true, and we will denote that as capital letter T. Next, proposition Q. Camiguin is in Mindanao. We all know that Camiguin is not in Mindanao. Therefore, this proposition is false, and its truth value is denoted by capital letter F. Lastly, 3 plus 2 equals 15. That is false, right? Since 3 plus 2 is only equal to 5. Therefore, the truth value of proposition R is false, which will be denoted by capital letter F. Okay? Whether it is true or false, the declarative sentence or sentences here are proposition. Each one of them is a proposition. Either it's true or false. Okay, let's proceed. Now, let's talk about simple proposition and compound proposition. Let's begin with simple proposition. Simple proposition. It is a proposition that conveys one thought with no connecting words, only one thought. Okay, for us to illustrate that, here are some of the examples. Number one, we have here, berries are sweet. Only one thought. Second, a square is a polygon. Geometry is a branch of mathematics. School is a place to learn. Bella is a grade 11 student. Each sentences here conveys only one thought with no connecting words. Okay? So that is a simple proposition. Now let's proceed to compound proposition. A compound proposition contains two or more simple propositions, which we already discussed a while ago, that are put together using connective words. Now, for us to know what will be the process, what will be the operation in constructing compound propositions, I have here a guide represented by a table. The first column represents the connective words. The second, the symbols to be used. The third one is a type of statement representing compound proposition. Let's begin with the connective word and. Okay, this connective word is represented by a symbol, caret. You see the symbol? And this connective word in a statement, that statement is a conjunction. Next, we have the connective or. The connective or, its symbol would be a reverse caret or a Latin word called vel, V-E-L. And then when you see the symbol and this connective word in a statement, that statement is a disjunction. Next, we have the connective not. This word, it is symbolized by a tilde. When you see this symbol and this connective word in a statement, that statement is a negation. Next, the connective F then, represented by a symbol, an arrow going to the right. When you see this symbol and this word in a statement, that statement is a conditional statement. Lastly, if and only if, also written as IFF. It is represented by a symbol, this one, that is equivalent in math. So when you see this symbol in a symbolic form of a statement, and you see this connective word in a statement, that statement is a biconditional statement. Now, let's discuss them one by one on the following slides. Okay, let's start. First, we have conjunction. So when can we say that a proposition is a conjunction? That is, if two simple propositions, P and Q, are connected by the word and. Take note, there is a word and. Then the resulting compound proposition P and Q is called a conjunction of P and Q and is written in symbolic form as this one. This will be the symbolic form. Okay, let's have an example. I have here two propositions. Proposition P states that tomorrow will be a sunny day. Proposition Q states that the weather will be hot. And for us to connect this word using conjunction, okay, we will be connecting them by the word and. So the solution would be this one. The symbol is read as conjunction of P and Q means tomorrow will be a sunny day, the first proposition. Then the word and, the weather will be hot. So that is now the process of making the conjunction of two propositions here. So the symbol, this one, caret, is called the conjunction. Okay, next. Disjunction. If two simple propositions P and Q are connected by the word or, take note, the word or, then the resulting compound proposition P or Q is called a disjunction of P and Q and is written in a symbolic form as this one. Okay, I have here two propositions. Proposition P states that tomorrow will be a sunny day. Proposition Q, the weather will be cloudy. Okay. So how can we connect them using this junction? Okay. So in symbols, that is, this junction of P and Q means tomorrow will be a sunny day. Then after the first proposition, we will connect them the word or. Or, then the next proposition Q, the weather will be cloudy. So let's reread. Tomorrow will be a sunny day or the weather will be cloudy. And the symbol inverse caret or vel is called the disjunction. It represents disjunction. So that is disjunction. The two propositions is connected by the word or. Next. Negation. It is an assertion that a statement fails or the denial of a statement is called negation of the statement. The negative of a statement is generally formed by introducing the word not. Take note, there is a word not at some proper place in the statement or by prefixing the statement with. When you say prefixing, putting words or phrase before the statement. So what will be the phrase? It is not the case that or it is false that. So ito yung ilalagay natin bago ang statement. The negation of a statement P is in symbolic form is written as this symbol, a tilde and then the letter P. Examples. So I have here a proposition P stating that tomorrow will be a sunny day. So how can we convert this statement into a negation? So we have three ways: by using not, by using it is not the case that, and by using it is false that. First one, by using not. Tomorrow will not be a sunny day. Will not be a sunny day. So we use here the word not. So we place the word not between will and be. Okay, the next one, the next solution would be, it is not the case that tomorrow will be a sunny day. So we have the prefix here. It is not the case that. Next, we have it is false that tomorrow will be a sunny day. So we use the prefix it is false that. So we have three ways in writing a proposition into a negation. So ito na yun, negation na to. Okay? That would be the solution. Next, the second to the last, if is a conditional statement. So that is when two simple propositions P and Q are joined by a connectivity or a connective F then. Take note, there will be a word F then. Then the resulting compound proposition, ito yon, if P, the proposition P, then the proposition Q, we're gonna have to connect them, is called a conditional proposition or an implication and is written in symbolic form as this one. P, then an arrow going to the right, then Q. In here, P is called the hypothesis and Q is called the conclusion. So the proposition, the first proposition will be the hypothesis and the second proposition is the conclusion of the said conditional proposition. So now I have here two sets of examples. Number one, if Kevin studies math lessons, then he will get high score in the exam. So first statement, Kevin studies math lesson. This is a hypothesis. Then the conclusion, he will get high score in the exam. So this will be our conclusion. So why we have this conclusion? Since our hypothesis is this, Kevin studies his math lesson. Okay. Next, we have, if Jam is good in math and science, then she is a STEM student. So our conclusion here is she is a STEM student. Why? Why you concluded that she is a STEM student? What is your basis? So you have a studied guess. That is, your hypothesis is that Jam is good in math and science. Therefore, you concluded that she is a STEM student. So this is a conditional statement. The first statement here, first proposition is the hypothesis and the second proposition is the conclusion. There is a hypothesis and a conclusion. Okay, there's F then. That is conditional statement. Next, last one, by conditional statement. So by conditional statement, we can say that a proposition is a biconditional statement. That is when two propositions P and Q are connected by a connective if and only if. Okay, take note of that word, the connective. Then the resulting compound proposition would be like this. So this will be the format. We have here the proposition P connected by if and only if, then followed by a proposition Q. Okay, and this format is called a biconditional of P and Q, and is written in symbolic form as P, then the symbol for equivalent, then Q. The proposition may also be written as P if and only if Q. So this is a symbol, IFF, that is read as if and only if. Then the propositions P and Q are the components of the said biconditional. Okay, we have here the first example. Jessa is a with honors student. If and only if she gets a general weighted average of 90 and above. As you can observe, the first statement refers to a conclusion, and the second statement refers to a hypothesis, wherein the conclusion is only limited to only one hypothesis. There is only one condition, just only one. Okay, next. The food is spoiled. If and only if it smells bad. So the conclusion is that the food is really spoiled. And the hypothesis is only limited to this statement. That is, it smells bad. So that is by conditional statement. You can see the word, the connective if and only if, and that the hypothesis is on the last part and the conclusion is on the first part of the statement. Okay, so this will be the last type of compound propositions. So I hope you learned something from our discussion, and thank you for listening.